Good morning. Welcome back. Today we'll be discussing Chapter 9. Chapter 9 is called Records or Data Structures, Structs. So this chapter is a shorter chapter. Even if you look at the slideshow we have available on our LMS, we only have 22 slides. If you exclude the objectives and the summary slide, literally we're talking about 18, 19 slides. It's a much smaller chapter. And this is the continuation of arrays concept. And in fact, last week when we talked about arrays, we talked about arrays are a collection of fixed number of components of the same type. So fixed number of components of the same type. However, the data structure is also a collection of fixed number of components or members, but of different types. So this gives you more flexibility. So you have different types of data which can be included in your data structure. There are various advantages of data structures. In fact, in C language, many years ago, we used to use data structures. And at the time when we were using data structures in 70s and early 80s, we didn't have a concept of object-oriented per se. And object-oriented concepts were introduced in 80s. So then gradually we made a transition. We made a transition from, in fact, I'm going to correct a mistake here. My brain sometimes runs faster than it should be struck here, and it should be employee here. So I was running too fast with my brain. What it means is this is the data structure I'm trying to create, and it has two members. And that's the name assigned to this data structure. That's the name assigned by the developer. So a developer is saying, I would like to create an employee, which is a data structure. And typically, this is the body of the data structure. It ends with a semicolon. Next week, when we talk about classes or object-oriented programming, I will be removing the word struct, and I'll be placing the word class. And it will become a class. It will become an object-oriented component. Now, there are additional things in classes. Classes are much more complex. Data structures are much simpler. In fact, data structures, they have various advantages, and we'll see that what are those advantages. One of the things I would like to highlight here when we are discussing data structures that we are limited with the types of data we have available in these classes. In our C++ or Java or C#, we are limited. We have integers and doubles and characters and booleans and strings. What if I want to create my own data type? I would like to create something which does not exist as a basic data type in that language. So we have a flexibility we call struct or data structure where I can create my own data type. So this is the data type I intend to create, employee or a customer or a product or a building. So these are the data types you are creating. And inside the body of the data structure, you provide what are the attributes of that type of data you're creating. What are some of the things associated with that employee? So, and in a real sense, in a real organization, an employee will be much more complex. It will have so many different types of attributes or characteristics, or we call them properties. Here, just to keep it simple, I'm highlighting two of these attributes. I'm saying this employee has a first name, and this employee has some kind of age. And we can add a lot of things. In a real organization, you will never create age as a basic variable because age can be calculated. Anything which can be calculated should not be a basic variable. It should not be a basic data type. You should take a date of birth and the current date, and you can calculate the age. But here, just to keep it simple, we have the first name and an age. We might have employee ID. We might have last name. We might have address. We might have zip code, and a lot of other things can be added to the employee. You guys are following? So for example, in my organization, I say, you know what, I would like to create a student. And the student can have different types of data. Some data might be double, some data might be integers, some data might be even other types of objects. It's possible. I have a student, and student can contain something which is not a basic data type. So I can have a data structure within a data structure as well, which we'll see in an example in a few minutes. So if you look at, let's go ahead and turn on this PowerPoint. So some of the things we would like to highlight And hopefully we can capture the whole screen. I would like to keep this one on. So we'll learn about what are the data structures, which we just have started, examine some of the operations, some of the actions we can take on data structures, especially when it comes to passing a data structure from one function to another function. That's the main strength of the data structure, because you're declaring a data structure and it can have hundreds of different attributes, and you can simply pass one data structure type to another function and you have access to all other attributes. So what I'm trying to say is, if you have 100 of these attributes, you do not have to pass all of them one at a time to another function. That will be too cumbersome and difficult to handle. Instead, you can simply pass the data structure type of content, and it can be captured on the other side. We'll learn how to manipulate using a data structure, how to modify the data, how to access the data, the relationship between data structures and functions, how to pass to other functions, and examine the differences between arrays and data structures. In fact, we'll learn in our second demo that you can actually create arrays of data structure type as well. And in fact, in my demo file, I'll show you two-dimensional arrays of data structure types, and how arrays are used in data structures, how to create an array of data structures, and how about create a struct of struct type, data structure of data structure type. Okay. All right. So this is on our whiteboard. It says a collection of fixed number of members, and they may be of different types. So the syntax says you use the keyword, the word struct. You start with a curly brace, close with a curly brace, ends with a semicolon. Typically, the data structure comes before your main function. It's above your main function. Or if you have a header file, it goes in a header file. Because if you are trying to create a member of data structure type, or I should say object of data structure type, then it needs to know what exactly this data structure entails, what exactly is included in the data structure. And this struct name is assigned by you based on what kind of data structure you would like to create. And here's an example. Here's a house type. And house type can have many types of attributes: number of bedrooms, number of bathrooms, square footage, and a lot of other things. Right? And house type is the data structure name. Then when you come to a function, such as main function, you say this is the house type, and that's the declaration of that type of variable, new house. Or in other words, when you come to the main, if I like to create employee in the main, here's my main, and I can say employee, part-time employee. So this part-time is a variable of data structure type. Could be a full-time employee, could be a staff, could be a contractor. Different types of employees can be created. So this is a variable of this type. Now you say, well, what do you mean by that? Well, what if I say this? I say int num, and it makes sense because I'm saying this is num is a variable declared by me of this integer type. So the C++ compiler understands what this num means. And C++ compiler can create that kind of variable in the memory. Same is true here. It understands this part-time PT variable of this type. So it can actually refer to this particular data structure. It knows this part-time employee has these attributes. So same thing we are doing here. This new house has a price. This new house has a tax. This new house has year of build, and so on and so forth. So this new house can access all of these attributes of the data structure type. You guys okay with that? Okay. Just want to make sure that I capture on the screen, on the camera, because sometimes I forget that it doesn't capture the whole thing. So hopefully it's visible there. And when you have created this new house of data structure type, the compiler goes to the memory and creates appropriate space in the memory, appropriate holding area in the memory. There's nothing stored there yet because I have not populated that area yet. But based on what type of members you had, if the price is a double, you probably have certain number of space bytes, 8 bytes. If it's a integer, 4 bytes, so it's actually holding on to that memory, which is available to that data structure. So if you want to visualize it, this is what it looks like in the memory. So that's a new house, and these are the attributes of that new house.
It kind of looks like an array, right?
Array is of same type. So data is of same type. Here, data is of different type. So that's why the definition looks kind of similar as well. And if that's how it started, that arrays are collection of fixed number of components of the same type. Here it's of different type. And but the good thing is you can create an array of data structure type. And we'll do that in a minute or so. Okay. So how do you access these attributes of the data structure type? So once you have created this part-time employee of that part-time of this type, how do you access these members? How do I access the first name? You access with the dot operator. So if you say pt dot, and it's going to show you all the available attributes or properties of the data structure, including first name and age. So I can say fname, and I can populate that value. I can say Joe. So Joe will be populated there in the memory for that first name attribute for that data structure. If I would like to display it, I can simply say cout part-time dot fname. So it will be displayed for us as well. And that's how you can access them. What if this was an array? Same rules apply, and we'll do that. You can make an array here, or you can make an array over there. So we'll actually go through that exercise together in a few minutes. Okay, so dot operator will allow you to access the members of the data structure. And just like over here, we created a new student. New student is a data structure, and dot GPA, and that's how you can populate the data. Once you actually have populated data, it goes to the memory and creates that data for you. You guys okay? This is really simple, especially after we have gone through the similar concepts in arrays. So this is really simple stuff. So value of one data structure can be assigned to another data structure. So let's say I have two data structures. One is called student, and another one is called new student. So when you say assign the new student to the student, it copies the contents of new student to the other student, assuming they are exactly the same data structure. So if I have part-time 1 and part-time 2, if I say part-time 1 equals to part-time 2, the content of part-time 2 will be assigned to part-time 1. And it verifies, or it copies one at a time. And we'll see in a slide, it takes the first name from part-time 2 to assign to part-time 1. It takes the age of part-time 2 and assigns to part-time 1. It copies that way. So all the contents can be assigned or given from one data structure to another data structure. Here's an example. So when we say student equals to new student, takes the first name, assigns to the first name of the other data structure. Takes the last name, assigns to the other last name. And it continues in this way. Here's the last item, GPA of the new student, assigned to the GPA of the student. So it's really easy to copy the contents of one data structure to another data structure. Okay? Simple stuff, really simple stuff. And honestly, this is how simple it is. But this makes your programming much easier as far as, especially when you're passing to other functions. However, your book says, your author says, variables cannot be compared like this. This is not feasible. So this is not okay. If I have if part-time 1 equals part-time 2, this doesn't make any sense. And you say, well, why not? Because you said I can do this part-time 1 equals to part-time 2, I can assign the contents of this to this, but how come I cannot check the equality? What do you think? What is the logic of the developers of this language? Why I cannot do this? I can do this, I can assign it, but I cannot check the equality.
Is this assuming the contents are equal?
Because in this case, we do not know what exactly I want to compare. Do I want to compare a specific value, like zip code, or do I want to compare the entire data structure? It's not specific enough. So the developers of the language said, you know what, you need to be a little bit more specific. So if you want to compare their last names, or you want to compare their salaries, or whatever you want to compare, you need to be more specific. So it's saying no aggregate relational operators allowed. So there are 6 of them. Equal, equal, not equal, less than, greater or equal, and greater or equal. None of these relational operators are applicable as an aggregate. So I cannot also do this if part-time 1 is greater than part-time 2. That's also illegal. So that's illegal because I'm not specific enough what exactly I want to compare. So to compare the values of student and new student, you need to be more specific. That's what it's saying. If student's first name is equal to new student first name, and student's last name equals new student last name. So it wants us to be more specific. Okay? So of course there are some limitations when it comes to, and it makes some sense because it is quite possible that you completely have a different data structure, and now you're trying to compare with your data structure, so it's not really compatible. You have to be more specific. So that's why that aggregation, relational operators are not possible. So no aggregate input-output operations on a struct variable. Data in struct variable must be read or write one member at a time. What it's saying is, this is also not making any sense. Part-time 1. This doesn't make any sense. Because when I say I want to display it or I want to read it, I need to tell the compiler what exactly I want to display. Do I want to display the first name and last name and address? Or I want to display all the members. So this kind of cout or cin will not be also acceptable. So these are some of the limitations. I have to be more specific. Cout, first name. Cout, last name. Cout, GPA, one at a time. Because I might want to just pick up only 2 members, not all the members. So again, the developers of the language, they said, you cannot just do cout and cin that way. Be more specific about it. Okay? And we'll be doing these things in much more detail. This is the main reason we use data structure. I shouldn't say that, but this is one of the strengths of the data structure. So you have created a very large data structure. Let's say this is sitting above your main function, and then you create a part-time member or part-time object of the data structure type or variable of that type. Now you can pass this one on to another function just like this. So you can say, you know, I intend to pass this one to another function, read function. And I'm going to just simply say PT part-time. That's fine, part-time. I'm going to just pass it on. Imagine if this part-time employee had hundreds of these attributes, and you can simply say part-time pass as an argument, and it will be captured in the read function. This is the really, really powerful idea, because if you don't have a data structure, then you have to specifically say, I'm going to pass first name, I'm going to pass last name, I'm going to pass GPA, I'm going to pass courses, all these things individually in a specific order. Here, simply pass the data structure, and then you can capture it like this. So let's assume this read function is a void function, and this is what the read looks like. Read is capturing part-time. You need to tell what is part-time. When we passed a number, we said number is an integer, right? So the other function knows how to handle that variable. So what type of data is part-time? So part-time is what type of data? Employee, absolutely. So I need to be specific here. A lot of students get confused. Well, I don't understand. What do you mean by employee part-time? Well, what if I say int num? You say, yeah, I understand that because I've spent a few weeks on that one. That's exactly the same thing. Here I'm telling the compiler, I'm passing you this of this type. That's what I'm saying. I'm passing you this of this type. So compiler reconciles that one. So once I'm actually inside here in this read function, I have access to all the members here. Okay? All the members are available, all 100 of them, assuming we have 100 of these members. If I don't have a data structure, arrays are not going to work. Because remember, we talked about parallel arrays. You need to have a parallel array for first name, last name, ID, all these things. You still have to pass all of them. That doesn't work. But if I have a data structure, I can simply pass one variable. I can capture it. I have access to every single thing. So how do I access it? I can simply say part-time dot, and I'll have the access list of these things will be available to me, including all these things. This is really, really powerful. This makes our coding much easier. A struct variable can be passed as a parameter, as a value, or as a reference. We'll pass both ways. This is a pass by value. How do I know pass by value? Because there's no ampersand sign. So this is pass by value, which means there's a copy made in this function, and there's a separate copy sent to that function. So they're looking at the separate memory locations. So if this one populates the data here, it will not be visible here. So in some situations, it might not be useful. You say, well, I can return the data structure type data. Yes, we'll look into that issue as well. So here it is. So student is being passed of student type, and you can access the data or you can populate the data based on what kind of function you are invoking. So then it compares in this chart arrays and data structures. So arithmetics, this is talking about aggregate operations. Can you multiply part-time employee with full-time employee? No, you have to be more specific. So just like what we did earlier, we cannot do relational operators. All the relational operators are no-no. Similarly, all the arithmetic operators, you have to be specific. When you say, I'm going to multiply part-time employee with full-time employee, we don't understand what you're saying. Because are you talking about their salaries? Are you talking about their first names? You cannot multiply first name of one data structure with another. You have to be more specific. Assignments, you can assign in data structure. Yes, we saw that one. One data structure can be assigned to other data structure. Assignment doesn't mean that quality. Assignment means just we can copy the contents. Inputs and outputs, we cannot just take all the inputs. We have to be more specific one at a time. Comparisons, no. And we can pass by value or references. Arrays are naturally passed by references. So arrays, it's not a problem. Arrays by default are passed by references. And function returning a value, yes, we can return. I already mentioned that one. We can return a data structure type of data back, which makes a really powerful way to access the data. So as you can see, there are more yeses for data structure. And especially when we make a transition to object-oriented programming next Saturday, you will see that it gives you a lot of power. Because in object-oriented classes, not only you have the variables, you have all other methods available. And there are so many different types of methods, constructors and destructors and accessors and mutators and all different types of methods, which we'll be using that terminology next Saturday. So arrays in data structure, 2 items are associated with a list, values or elements, how many elements in an array, and length of the list in array. Those are the few things we need to be aware of in arrays. You can also create, notice that in this case, and we'll see some examples in my demo file as well. So here's your data structure of list type. It has 2 members. If you look at the next member, this is the length member. Just gives me the length of the data I want to store. Let's say 5 or 15 or 50 or 100, whatever the length is. And these are the elements. This is the data. This is where I would like to store the data of this type, integer type. And this element is actually an array itself. So which means I can, whatever the size of the array is, I can create that many array elements or array members within the data structure. In this case, it's 1,000. As you can see, array size is 1,000. 1,000 of those pieces of data can be stored in that data structure. So now you're seeing that it can be implemented. So literally, so that's your length. Length is 1,000, and these are all the elements which can contain the data. So 0 through 999. And then you can populate them one at a time. So 0th element, the first element, and second element, and on and on. Okay. So what if you have this data structure? Nothing fancy about it. It's just an employee type. In my case, I call it employee, and I just had the first name, but it has some additional data, last name, and some additional data. And then, what do you see here? What happens here in this case? So employee type is, employees are what? It's an array of size 50. So now we are creating a data structure type of data with an array. So this concept is different the concept we had earlier. So for example, if I say I would like to have 2 first names, so this is an array within a data structure, then I come back here, I say I'm going to create 50 of these here. So this array is, it means we are creating 50 data structures, part-time type. And each 50 data structures, or each member of part-time type of employee, has 2 first names. See the difference here? So this one gives me 2 first names. For example, if I want to have 2 first names, or we can just call it name instead of first name. So this gives me 2 members of array type. On the other hand, this one means I have 50 of data structure types. And we'll learn how we actually access them and populate them. And that's what's showing you here. So you have 50 employees. Each employee has access to this data. Each employee. Employee 0, employee 1, employee 2, all the way to employee 49. Okay? So that's how you can create an array of data structure type. And you can also create data structures of data structure types. Okay, I don't have much space, but I'll show you in a few minutes that we'll actually create 2-3 different data structures within data structures. So here it is. You have new employee, and new employee information is there, and this could be address could be a separate data structure. You can have a separate data structure of address type. Name could be a separate data structure. Okay, so that's it. We are done with the chapter, so I'll actually spend more time, and we'll spend a lot of time discussing our code now. But somebody asks you in the interview, what is a data structure? How would you define it? So Salim, it's right there on the whiteboard. It's
basically it's like creating a. To me, it seems like it's just a table with a lot of attributes.
Okay, so
like,
table.
Well, yeah, you define an employee is basically the table, and each data within the data structure is an attribute to that employee.
Right.
Yeah. So it's just the easier way to contain all your data rather than defining it outside
Sure.
in the video.
Absolutely. Okay. Anybody would like to add something to it? Daniel, how would you define a data structure?
Data structure, strictly speaking, in the abstract sense, typically is a type that expresses certain operations and behavior.
Okay.
When thinking about its implementation, it's just a series of elements of different types.
Different types of members. Okay. Sure. Anybody else in the back? So, do you think people will ask you these things in your interview? Yes. They are going to be very specific. Very specific. I can tell you, they will just, if you are applying for a database administrator job, they are going to be very specific. If you apply for a programmer, coder, developer, app developer job, they are going to be very specific. They will ask you very specific questions. They are not going to ask generic, high-level question. They will ask you, okay, show us how to create a data structure. And if you have the clear concepts, you will say, well, data structure is a fixed number of components. It's a collection of fixed number of components of different types. So you can actually create different types of attributes in a data structure. Why do you want to do that? Because for ease of use. You create a data structure first time, then you can easily pass to other functions. Instead of passing 50 or 100 different attributes, you can simply pass one data structure. Just like what we did here, assuming we have 100 of these members of different types. And then I can easily pass on to another function. So that's really power behind it. So let's take a look. This is what we have on the Moodle side. So I'm going to show you this one. So that's the data structure I have on the whiteboard. So I have an employee. Employee has a first name and age. Notice that this data structure comes before the main function, because when I come to the prototype or main, so it needs to know what is an employee. If I have not provided this employee data structure, this will become ambiguous. So it's going to give you a syntax error. So it needs to come before that. Or it could be part of your header file or library.
Do you need that library to be able to use data structure? I haven't seen that one before.
Not really. No. I'm not sure why I have that library. So you can get rid of that library. Maybe I was using something specific, but and here is my main function. Remember, we started using main function as a driver function. We should not be putting any specialized code in the main function. So all I'm doing is creating a member or variable of employee type. I'm calling it person. Person is an employee. What is an employee? We can refer to that employee data structure. And then I'm passing this person to read function. Any question about this one? Yeah, Clint.
Is the read function like a default? Is it already defined?
No. It's our function. We are creating this function.
And does it, when you run the function, does it just print it out?
So read function?
Yeah, I'm just looking.
Read function is going to just populate the data. So read function is not print. It's just going to populate the data. We can have another print function, but in this read function, I'm just populating and displaying just for verification purposes. Here's my read function. So read function is a void function. It captures the person as an employee. So read function knows person is an employee. And read function says, what is an employee? Okay, employee is available to me. I know what employee is. I can refer to that employee.
Is there a reason that it was listed up before?
The prototype?
Oh, was that just?
That's just a prototype.
Oh, okay.
That's just a prototype. So when I call read function, if I don't have this prototype, the compiler says, I don't know what read is. So it's a declaration of this function. So when it comes to this line of code, it says, oh, you know what? I saw this somewhere. I'm going to find it. So it looks for the read function.
Do you need it?
Yeah. If you don't have the prototype, then you have to place the body of the read function above it. If I comment it out, if I run it, and the error message is, I don't know what the read function is. Read not found. Read identified not found. It doesn't know what read is. So it's just pointing in that direction. As you can see, it's blinking. I don't know how to resolve that issue. So in order to solve this problem, I have two choices. One choice is A bad choice is take this entire read function, take this one, cut it from here, and put it above the main function. Now it's resolved because the body of the read function is already available. Compiler has gone through that one. When I make that call, it says, oh, you know what? I know what read function is. But what if you have hundreds of these functions, and each one of these functions are calling each other? How do you know which goes where? That will be almost impossible to position every single function in such an order that it's in the right place. So that's why, in order to resolve that one. But in a real system, which you'll learn in CS12 and CS22 later on, we don't even worry about these things. We put them in a separate file, separate their own files. So in that way, that issue can be resolved as well. But right now, I'm going to just take this read function from here. I can place it in any order, anywhere. But I also need to provide this declaration. And this is called the prototype. Okay, so then this can be accessed. All right, so my read function is a void function because my read function is basically going to populate the data. And then I pass the person. And I don't really need these local variables. I'm going to comment out these local variables. Actually, let's get rid of them. So when I say person dot, it shows me the drop-down list of all of the hundreds of attributes of the employee, assuming we have hundreds of these attributes. In this case, we only have two, first name and age. So those are available to me because of the dot member access operator, dot operator. I can select what I'm looking for. I can select it, and then I can populate it. In this case, I'm reading from a user. Then, just to verify that I can display this content, I'm displaying it. And that's it. That's all this read function is doing. So let's run it. So I jump to the read function. It's asking for the name, as you can see right there. I said the name is provided, age is here, and then it verifies the information and produces the results as expected. So again, for the camera, so I actually did the inputs, and I verified the results are available to me. My C-in and C-out worked for my data structure. Now, one thing which we discussed, we cannot do an aggregate function like this. We cannot say C-in person. Let's try it. When I run it, what kind of error I get? And let me show for the camera. So I tried to take use C-in or C-out for person. The error message I get is no operator greater matches this operator. In other words, it's saying I don't know how to apply C-in to this employee person employee. It's not possible to apply. You need to be more specific like this. You need to be specific like person.first name or person.age, but I cannot do that. Same thing with C-out. Those operators are not applicable. However, when we come to CS12, some of you will join us in CS12, then we'll overload. This is called operator overloading. We'll overload these operators. We'll tell these operators, if I give you a command like this, in the background, this is what you need to do in order to reconcile or resolve that issue. So we'll overload every single operator, all the 6 relational operators, all the arithmetic operators, and all the logical operators. We can overload all of them, except there are 5 of them we cannot overload. But all of these operators can be overloaded. I remember I was in one of the interviews, and the interview committee asked me specifically, show us how to overload operators in any language. And if you do not know exact syntax, it's not going to work. There's a specific syntax to overload an operator. So I know some of you are not understanding what I'm saying, but notice that this is giving me an error message. This error message is the compiler is saying, I do not know how to resolve it. And that's what it's telling me. I don't know how to match this one with that data structure employee or person in this case. So I can tell the compiler, this is how you can resolve it. That's called overloading operators. So we'll do that in CS12 together. And it's not very difficult. It requires specific syntax. So that's why this is illegal. Now I'm going to ask you a question. So I'm going to copy this content here, put it in the main function, and in main. Let me ask you this. When I populate the data, I'm populating the data right here for the camera. I'm populating the data right here. And I verify the results are available within the read function. When I go back to the main function, question for you is, can I see these results? So I populate the data here. I can verify the results in the read function. When I go to the main function above, can I see the results? Yes or no? Yes. One no, one yes. Others are not interested. You want to guess? Just guess. No. No. Daniel is saying no. Okay. No is the right answer. So when I come back, I populate the data. Is Mary. She's 19. And this is in the read function. I can see the results in the read function. I come back to the main function. Nothing in the main function. Actually, this line was supposed to be right next to it. So let me just correct that. So this one, I'm going to get rid of this ENDL. And I'm going to put ENDL here. And try again. So Mary, 19. And here I'm actually in the main function. No data is in the main function. Just for the camera, I just want to verify. So the data is available in the read function, but data is not available in the main function. It's missing in the main function. Who can tell me why it's missing in the main function? Other than Daniel. There's a concept of pass by reference and pass by value. This looks like pass by value. How do I know that? Because there's no ampersand sign. It's a pass by value, which means the person in the main has its own memory space. Person in read has its own memory space. There are two persons at this time. They are not the same. You say, well, that's not true because this is the same spellings, person, and that's the same spelling, person. That doesn't make any difference. There are two separate memories they're pointing to. So that's why when I go back to the main function, it's pointing to the empty space, and there's no data to be displayed. How do I resolve this? With one operator, ampersand sign. So simply by putting ampersand sign here, if I put ampersand sign here, I need to resolve this one. I need to put it here as well in the prototype. So simply by putting this ampersand sign right there, I can resolve this. So this time when I populate the data, let's try again. So I'm going to populate the data here. I'm typing Mary and 19. So this time, here's my Mary and 19 from read function. Here's the main function. I can see the data is available. Oops, camera is actually pointing in the wrong direction. Let me put this one here so we can capture the whole thing. So you can see this is my main function. Data is available. Just by putting one ampersand sign, because both functions are pointing in the same memory location. That's one way to solve this problem. I'm going to ask you to help me solve another way. Let's say we are not passing by reference. We say, for whatever reason, I'm not interested in passing by reference. I'm just going to pass by value. How do I solve that problem if I'm passing by value? Again, my goal is to populate the data here, but I want this new data to be visible in the main function. How do I solve that problem? Return, absolutely. Return what type of data? Salim? So what exactly we populated? Person. So I should return this person back. Let's try it. So what I'm saying is we should type this line of code right there. Return person. Again, for the camera, I just typed this line of code. Return person, because person is the data structure type of variable. So I'm returning that one. Right now it's telling me you cannot return person because you have a void function. That's why it's giving me that error message. And that's true. Let me see if I can put everything in one screen. It's telling me I cannot return person because your function is a void function. So I can resolve that issue. I can resolve that issue because it's a void function. What type of return should I return? What is person? Person is of what type? Person is an employee type. So I should be returning employee. Of course, when I change my function here, I have to change here as well in my prototype. So, okay, so again for the camera, I'm going to just highlight this one. So I'm returning a person, and person is an employee type, as you can see right there, employee type. So once that is resolved, this person which is populated here should be visible in the main function. I'm going to play a trick here and run this code, and let's see what happens. I run this code, and I type Mary. She's 25 now, and that didn't happen. As you can see, we were thinking it's going to happen because I'm returning a person. Didn't happen. Come back to the main. There's no data. What happened?
You didn't assign it to something in the main.
Right. That's right. You're hitting the target. Yes. So what I did, I returned it, but I never captured it. You're absolutely right. So I returned it, and I'm calling the function right there. But am I capturing the incoming person? No, I'm not. So I'm missing that piece here. So how do I capture it? How do I capture right in that line which is highlighted? How should I change it so the new incoming person is captured, the data is captured?
You assign it to it.
So I will assign like this. So I'm passing you an empty person, which means no data was assigned to this person. I'm going to pass on to the read. Read has the ability to populate it. Once the data has been populated, return back to me in the same data structure so I can start displaying the data. Okay, let's try that way. So when I run it, I try the data and try this one, and this time it worked. This time I come back to the main function, data works. As you can see, because I returned, captured it, then I start displaying first name and age, it worked. So now we see two ways to return the data. One was by ampersand sign. One way was to return the data structure itself. Now I'm going to make it a little bit more interesting. I'm going to say, you know what? I don't want to use ampersand sign. I don't want to return of that employee type. I still want to keep my read function as a void function. And I still want to display the data in the main function. All right, let's go back what I just stated. I don't want to capture it. I'm going to keep my function as a void function and keep this one as a void function. If it's a void function, no return is possible. Okay, so for the camera, I just want to verify there's no return in the read function. Read function remains the void function, and I'm not returning anything. I'm not passing any as an ampersand sign, but I still would like to have the access to the data in the main function. What is the third way you can do it? another way you can do it. So what if I come back here and change this person into what? Here's a hint. That thing is by default returned by reference. What do we call that thing? An array. Absolutely. So if I change this to an array, let's say 100 of these members. So what I did for the camera, I said person is an array with 100 of these fixed number of components of the same type, of the same employee type. All persons are employees. That's what I'm saying. All 100 of them are employees. And now I'm going to send this person. I don't have to say return, and I don't have to use the ampersand sign. And still I'll have the access to the data. So this makes your coding a little bit more useful. And on the top of that, now you have 100 of these employees, 100 of these contractors, or 100 of these customers, whatever the type of data you're creating. I have to make a couple of changes here. So I have to tell this one, it's an array, just for the camera. So I have to change my prototype. I added square brackets, so indicating it's an array. I have to change my function header. I have to say it's an array. And again, for the camera, let's change your header. Keep the function as a void function, but I'm putting the square brackets, so this function knows it's an array. And because I'm changing as an array, so I have to change here as well, assuming we have only one person at this stage. I'm not going to run some kind of loop here. And I'm just putting a square brackets and the 0th element. I'm adding the index there. As you can see, I just added those indices, 0th index, so it means only one element of that person employee type will be created. And because it was passed as an array, so by default it's a reference pass. Okay, no return, no ampersand sign. When I go back to the main, so I have to change one thing in the main as well. So I have to tell which element I'm referring. I'm referring to the first element. So I come back to the main. So I'm referring to the same first element. And this is the beauty of the array data structure. When I come back, it should be available to me. Right? Let's try it. Okay. Mary is 25. So this is in my read function, and this is in my main function. It worked out very well. And that's what you want to do. And not only you have this advantage that there's no need to return anything if read is a void function as we saw earlier, but you have 100 of these employees now. And all 100, they have access to hundreds of these things. You guys okay with that? Now if I go and tweak my age or first name, so let's discuss this one. I talked about this in the presentation. So I go here, I say, you know what? I'm going to have 2 of these for whatever reason. One is a nickname, one is a real name, one is a legal name, for whatever reason. So I just tweaked this one here, this first name. Right now it's telling me it's a mismatch, and we'll resolve that issue. So when I go back to my first name here, right here, so let's say I'm referring to the first element of that one. Same thing, the first element of my first name. Come back here, first element of that particular data structure. Okay, I'm going to show this on the camera. So what I just did, now I'm saying, okay, I already know my employee person is an array of 100 members. I already talked about this one. But not only that, my data structure member is also an array. My first name is an array with 2 members, or 2 of these first names can be created. One could be a legal name, one could be a nickname. So when I made the change there, I have to change in a couple of places because now first name is not a simple variable, it's an array. So I have to change when I'm trying to display it in the main function as well as when I'm trying to access in the read function. So I have to change in the read function as well. Change it there and change it here. Now what it does, it gives you an ability to store 2 first names for each one of those 100 employees, 100 persons. So right now you'll see exactly the same results. Same results. Mary is 25, and here it is, same result. But behind the scene, this person, Mary, can store 100 of these members. There are 100 members, and this is the member number, element number 1. And similarly, the name, she can have 2 different names, Mary and Maryam, for example. She's used a legal name and some kind of other name. You guys are following? Okay. So don't get confused if you see, and you will see, when you work for a company, when you work for other complex projects, you will see. Whenever you see the square brackets, just deal with it. It means you have the ability to store multiple of those things, not only one, multiple. And just by adding the square bracket and putting the proper index, you should be able to populate it or access it. I'm going to show you one more example. I actually have 2 sample programs on our LMS, but I'm going to just show you first one and the third one, because the second one was like kind of mixed in between. So I think I can exclude this one as well, and include this part here and this part here. Okay, if I can get your attention for a couple of minutes, because this will be a very interesting one. All right, so this is a simple data structure. It's called school. And assuming we have 3 members in this one, three components: school name, school city, and school zip code. And we can argue about it. We can further distribute it, and we can do this and that. But let's keep it simple. This is my data structure. Just remember this data structure is called school. It has 3 members. Then I come back to the second data structure. Here's my second data structure. Let's take a look at the second data structure. My second data structure is called education. Let's say this is the education of the student. School is the information about the school. Let's say Long Beach City College. Education is about that student. Okay. In that education, we have 2 members. One is called years. Simple. Years. How many years you have spent in that school? 2 years, 2.5 years, 3 years, whatever. And the second component in that data structure is called my school. My school is of school type. So my school, it refers to the previous data structure. So when I access my school, it refers to the previous data structures. My school has 3 members: my school's name, my school city, my school zip code. You guys are okay with that? So it's a data structure of data structure type. This is a data structure of this actually has a data structure inside, built in. Let's go one step further. And look at this one. The person info, that's a third data structure. Let's say this is specific to that individual, not the year spent, not the school information, but the person's information, the student's information. We have first name, last name, age, city, and some kind of qualification. This qualification is of education type. What is an education? Education has 2 data structures: years and my school. So how do I access school name? That will be tricky. So let's actually try to draw it here. Let's say I want to access. First, let's create person info. Let's say this is my main, and inside my main, help me guys, I want to create person info. This is the name of my data structure, and I want to call this one student. Okay, so I created a student, a person info type, which means this student has the access to first name, last name, age, city, and qualification. I'm interested in qualification. So I want to populate something about qualification. So I say student. How do I access qualification with which operator? Dot operator. So I put the dot, and it's going to show me qualification. So I pick up qualification because qualification is part of my person info data structure. So I should be able to access it because I'm creating a student of that type. So student variable can access qualification. But the qualification itself cannot be populated because it's a collection of other data structures. Okay. So as soon as I hit the dot notation here, it's going to show me a drop-down list of education. And under education, I have two things, years and my school. I'm interested in my school. I put another dot notation and put my school. Then under my school is also a data structure type. My school is not a simple variable. Then I put another dot notation here. Then it's going to show me what exactly is included in my school. So those are the three things included in my school. Then I pick up my school name. School name. And I can populate it. I don't have space here. I can populate it here. So this is how you can access create a data structure of a member of that type, in this case person info, access qualification, which is part of education, access my school, which is part of your school info data structure, then access a specific member of that data structure type. Now if you create this as an array, let's say you want to create 100 of these students, then this becomes more interesting. Then this becomes student and which element you're trying to access. So it's really a long call when it comes to accessing data structure of data structure of data structure type, and even the data structure you created is an array. And I'm going to go one step further. I'm going to create this as a two-dimensional data structure type. So I'll show you that one. Okay? Any questions on this? Okay. Why do I need to make it like this? Because most of you, anybody has taken a database management class? In database management class, you learned that you create an entity, such as a verb, such as just like we have thing, place, nouns. All these entities are created, and these entities should contain the data about that entity alone. So if I create such as school entity, I should not be putting teacher's information in there. Teacher's information belongs to teacher entity, teacher's table. Student information belongs to student table. So same thing, we are trying to set it up in such a way. If I want to create school entity or table, I should only contain school information. I should not be plugging in student data. Student first name, student last name, teacher's first name, teacher, building numbers and all those. Those things don't belong there. Although we have not normalized it, that's not the purpose here. But when you are developing your code based on the normalized database management system entities, then it has to be in such a way that you have secluded those variables within those entities. So they're encapsulated. And that's what we achieved here. All right, so let's take a look. How do I access? We understand how these three data structures are interconnected. So let's look at the main function here. Main function here. So here in the main function, I'm creating a person. On the board, I showed you person with person. I call it a student here, but here I'm calling it a person. So person is actually two-dimensional array, 2 by 2. It's a matrix which looks like 2 by 2. So if you want to visualize it, I'll actually put it here for you. So when I create this person of this person info type, this is what a person looks like. It's 2 by 2, 2 rows and 2 columns. And this is row 0 and row number 1. It's the first element, the second element. This is column 0, column number 1. And this person is pointing over here to the first element, to the first location. Okay? And I'll try to draw how it's going to access other data structures in a minute. But as soon as I run this code, person 2 by 2, it goes in the memory and creates something like this. And of course, person is not an integer, person is not a double, person is a person info type, which means it is pointing towards a data structure. Where exactly this data structure is. So let's say we are referring to person 0, 0, 0th row and 0th column. So we are referring to this one, this particular one. This is 0, 0. This is 0, column number 1. This is column 1, column 2. And this one is 1, 0. And this is 1, 1. Okay? So when I say 0, 0, person 0, 0 is referring to this particular location. And because I cannot just save the data there, it's not an integer, I can plug in the data there, it's not a character, it's pointing to another location. Another location. And this could be an address, some kind of address of this thing. So this thing, a person info, so I have to go back and refer to person info. Person info is collection of these things. First name, last name, age, city, and qualification. All right, let's just keep it simple. My first name is here, which I'm going to change in a minute. Last name is here. Age is here. City is here. And qualification. Qualification. Now, qualification itself is a collection of another data structure. Because qualification cannot be stored there. So when it comes to qualification, it points to another data structure. All right, so there's another data structure. Let's assume it has a memory location of 2000. So 2000 is stored there. It's pointing in that direction. So when we go to the qualification, it's a collection of years and school, my school. My school is a collection of another data structure, so it points over here. Let's say that address is 3000. And my school has these three things: name, city, and zip. So this one is address 3000. I'm going to go one step further just to show you visually or in the memory, this is how it's handling it. Here's an idea from last week. Because name and city, these are strings. Strings are by default what? Or implicitly strings are? Arrays. So arrays cannot be stored there because they don't have space. I don't have 4 bytes over there or 6 bytes. They are pointing to another location. So all the strings which I have here, here, and other places, they are also pointing somewhere else. Let's say this first name is, the school name is stored right here. Let's say this is the location. This is address is 5000. So it's actually pointing to another location. Same thing with this one, same thing with this one, same thing with the city, same thing with that city, and all these things are pointing in different directions. So that's how literally in the memory it's happening. And we can go and verify if we need to verify. We can look at their addresses and verify that information. So this is just one data structure. This is just 0th, 0th. This is person 0, 0. Then I say, okay, I'm going to create this one. Same thing happens behind the scene. It's creating all these memory locations, and the compiler is doing all the dirty work for us. We don't have to worry about it. But imagine if you created this as 100 of persons, 100 of these persons, which I did. Student have 100 types. So now you have a lot of these persons. Or you have 100 by 100. Literally you have 100,000, 10,000 of these persons created. And each one of these are pointing in different directions. Like first name is pointing in a different direction. Last name is, and also when we talked about strings in last week or week before, strings are immutable. So you change your mind and you say, I want to change the name of the person to something else. It's not going to just erase that location and put the new name there. It creates a new name somewhere else. It just changes the link or address to the new location. That's a different discussion. All right, so we understand how it's actually happening. So coming back to this one right here. So we understand we create person 2 by 2, and I'm passing this person to read function. Person is 2 by 2, and I'm passing it to read function, and later on probably to the search function. Imagine if you didn't have this as a data structure, you had to pass every single thing individually. And imagine if the person was a large data structure, education was a large data structure, school was a large data structure, how many members we are talking about? Let's say 100 in each, 300 or 400 members. How you're going to handle that from one function to another function? That would have been very, very difficult way of coding. Instead of doing all that funny thing, we can simply say, I'm going to pass you a person. We pass the person, we capture the person in this read function right there. We capture it. We tell this read function, person is a personal info type, and this person is a two-dimensional array. So we need to inform this read function it's a two-dimensional array. And then we can start accessing it. Accessing itself, because it's a two-dimensional array, you probably need 2 for loops or 2 loops. So here's my outer loop, runs from 0 through 0 and 1. Here's my inner for loop, j runs from 0 to 1. So first time is 0, 0. Both are 0, 0. Name will be populated, age, and last name, and other things will be populated. In this case, when it comes to name and first name and last name and age, that's not a problem. Even city is not a problem because they're right here. First name, last name, age, and city. When it comes to education or qualification, then I have to access another one of them. So when it comes to qualification, this is what I was indicating earlier. So let's actually talk about it for a couple of minutes. So here when I say I want to access the qualification itself is a data structure type. Then I say, okay, it's up for my school type, or it has access to my school, another data structure. Inside my school, I have school name, I have school city, and then I have school zip code. Those are the 3 members of my school type. And then under qualification further, I have something called years. So that's how I can access all of these members. Just for the camera, you can access all of these members here. So years is under qualification or under education data structure type. School zip code, school name and city, they are under, I believe, my school data structure type. Okay, so when we run this code here, and by the way, because person is an array, I don't have to say return anywhere. When I come back to the main function, all the data which was populated in read function should be available to me. When I come back here, if I want to test it, I can test it. I can display it. And it should be available because it's an array. So let's try it. So you might not be able to capture everything from there, but I'll demonstrate there. So here is my, very quickly, just some fictitious data. And this is okay, so I just populated this data, and this data is structured differently. Looks like just any other regular program, but it is structured in 3 different data structures, and it is in 2-dimensional array. So what we did, we populated only the first element of the 2 by 2 array, a person array. First element is populated, which means first element is pointing here, 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 and onward. And we verified the data was populated successfully. And it's asking for the second element, which I'm not going to populate. Okay? And this is how we do it. And then we can also search. If you want to search, you can search it. It's very similar to what we did last week as well. Okay, guys, any questions on this? Let me just bring this one here. Any questions? You guys can access. For the project number 9, you don't have to create two-dimensional array. There's no need. If you want to, you can, but you don't need to. If you use data structures and a single dimensional array, that should be okay. Let's talk about project number 9 if there are no questions. So project number 9, let's bring that one here. It's there's a handout available. So it says write a program for a local restaurant to automate their breakfast system. The program should do the following. So there are 3 things. Show the menu. Here's the menu. Allow the customer to select more than one item. Customer wants coffee and fruit basket. Allow them to select both of them. Not separately, but together. So you can actually have a number here assigned, 1, 2, 3, 4, 5, 6, 7, and 8. So the easiest way is ask the customer, what would you like to order? And have you seen the restaurants, mom and pop restaurants? Sometimes they don't have like touch screen monitors. They still use numbers, the older systems. The newer systems are touch screen, and we actually can easily develop those touch screens as well. But here, let's assume you have assigned number. Somebody says, I'd like to get a coffee and fruit basket. You can simply click this number and this number, 7 and 5, for example, and it should take that order. Now, if you're not using arrays, it will be difficult. So if you're using arrays, you can store multiple items. Multiple items can be stored in arrays because arrays allow you to have multiple items stored, 0th element, first element. So that's why you need to use arrays. And assuming these are the prices, and it's saying use an array of menu list type of data structure menu item type. So that's the name of your data structure. The book is giving you the data structure name. Book is also giving you the name of your array menu list. As defined, if you want to see the previous program, but there's no need. Your program must contain at least these following functions. So you must have these following functions. You can add more functions. The first function is get data. This get data is just read function. This function loads the data into memory. Now this file, I'm giving it to you. It's available on our Moodle site. You don't have to write this file. I want you to use this file already available to you. Let me just log in again. So just for the camera, for the students who are going to see this video in the future. So this file, the data file, is available right there. Menu data file. And you can download this or save this one into simple notepad. Notice that, let me see if I can move this one a little bit here. Notice that the way I have the data file, I have the name of the item separately and the cost or price separately. What if you want to put the name of the item and the cost in one line? Can you do that? It's doable, but it's challenging. I used to actually, this used to be part of our assignment number 9, that the name of the item cost was in one line, and then I asked the student, you figure it out where the name of the item ends, where the name of the cost of the item begins. And that was very challenging. So student wasted a lot of time on that one. So here I'm just giving you the data file. The reason it becomes challenging because there are some spaces. When you're reading the name of the item, space is the terminator. It stops at French and tries to pick up the toast as the cost. And it causes some issues for some students. There are ways around it. You can figure it out. But here, you don't have to worry about it. Okay? So pick up the item name and the cost of the item like this. It's really simple pick. Really, really simple. Okay, so that's your data file. Okay, let's go back here. We were right there. Okay, so that's your get data function, picks up the data. Show menu, this function shows the different items offered by the restaurant, tells the user how to select those items. So you go to the following page. So the function print check, based on what items you have selected, this function calculates and prints the check and also adds 5% taxes. As you can see, this is old handout. Things have changed, prices have changed, the taxes has changed. But I think it's a great exercise for us to play with arrays and the data structures at the same time. Right, so format your output with 2 decimal places. The name of each item in the output must be just left justified. You may assume the user selects only one item of a particular type, which means that I would actually make it flexible. If somebody says, I want tea, you can ask how many teas do you want, 1 or 2 or 3. You can give that option. But it will be a little bit more cumbersome. So here it's just telling you, the author is telling you, assume this user only picks 1 tea and 1 fruit basket. But I would love to see, I know some of you can do it, 2 teas and 2 fruit baskets. It's not very challenging. You just have to logically think how to resolve that issue. Honestly, it's really easy. So see if you can make it a little bit more versatile. Okay, that's our and your receipt. I would like to see on the black screen as well as in the output file. Okay, that's all I have, and that's